science. Alright, down to business. After a little weird science tunes, what are we going to learn today? It is scientific notation. What is scientific notation? That is just a way that scientists used to represent a number. Scientific notation is just a number. But it's how we represent numbers that are very, very, very big and very, very, very tiny. For example, the size of an atom, if I want to measure that even in millimeters, that would be a very, very, very tiny number. 0.000000, lots and lots and lots of zeros until I get to something. That would be a very tiny number. Your calculator doesn't like that number, and so you have to put your numbers into scientific notation in order for your calculator to recognize them. Or very, very large numbers, like the speed of light, or how many inches until you can, how many inches does it take to get to the moon? Very, very large numbers. Your calculator really doesn't like very large numbers, past just a few places. So we have to use scientific notation, and it has a pattern of a times 10 to the nth, where a is a number that is greater than 1 and less than 10 usually, and n is some sort of integer. So the rules for writing scientific notation is that we have a number, often followed by a decimal place and all these digits that are, as you've already learned, significant, times 10 to the n, and the n is a number that tells us how many placeholder values that we are representing. Okay, and n can be a negative or a positive number. It doesn't really symbolize negative and positive per se. It just symbolizes is it in the smaller direction? Is it less than 1, or is it a positive n, which means the number is greater than 1? So the best way to understand this is just to do a couple of examples. So here I have a number in scientific notation. I have my digit followed by all the numbers that are significant, and times 10 to the 5th lets me know that I am 5 decimal places that way. So I'm going to take my 6.02 and I'm going to move that decimal place 5 places to the right. Because that 5 is a positive, that lets me know that this number is greater than 1, so we're looking at a big number. So if I move that decimal place 1, 2, 3, 4, 5, then I'm going to fill in all of these other spaces with zeros. So 6, 0, 2, 1, 2, 3, 4, 5. And I get my commas. And so 6.02 times 10 to the 5th is 602,000. 6.02 times 10 to the minus 5th, that minus 5 lets me know that I am a number smaller than 1, and so I'm now going in the left direction. So I'm going to move 5 places this way, 1, 2, 3, 4, 5, and put my decimal place. All right, that's decimal place, 1, 2, 3, 4, 6, 0, 2. So 6.02 times 10 to the minus 5 is 0.0000602. It's a very, very tiny number. And going in the other direction, let's just say we want to write these numbers in scientific notation, and oftentimes this is actually the case. Remember, the pattern is that we want a number, some integer, with a decimal place, followed by everything that is significant, and then times 10 to whatever integer that represents the place value. Okay, so I want to get my decimal place like right there. So I'm going to move it and count the places. 1, 2, 3, 4, 5. So 3.240. Oops, yeah, my decimal point. All right, times 10. And this is going to be a minus 5 because this number is smaller than 1. All right, so here's my big number right here, and there's no decimal point, so this is a big number. Now, it's really right there, right? Like you would realize, like it's really right there. So we're just going to count the places because, again, we want the same pattern. We want a number and a decimal place followed by everybody who's meaningful and significant. So let's count the places. 1, 2, 3, 4, 5, 6. So this is 3.24 times 10 to the 6th. And that's how we would write this number in scientific notation. Now, we're going to do this in class a little bit, but in your calculator, you should know that there are two special buttons on your calculator you're probably unfamiliar with. One of them looks like this, EE. Sometimes you'll see it as a little E too. And then on some Casio calculators have this X10Y, and all these two buttons basically represent this times 10 to the value. We don't put actual multiplication like the actual times button and then use your exponent or your little e or something along those lines. This is not an exponent. It's a representation of an actual just number. Alrighty? That is scientific notation in a nutshell.